Hi everyone, I'm Alexandra. I work at Fellow.app where we're building a product that acts as a manager's co-pilot, so something that helps you organize your one-on-ones, collect feedback, take notes in team meetings, and track action items. So that sounds like something that would be interesting to you. Come talk to me after or check out Fellow.app. But today I want to talk to you about something completely different, which is a project I've been working on in my spare time. And this is an app that I built for my phone that lets you access the internet in a real browser without actually having to have a data or Wi-Fi connection. It transfers everything over SMS. So to give you a preview of what this is going to look like, on the left we have a screenshot of the app where you're going to enter the URL for the website that you want to visit. And on the right side, there's a screenshot from my default messaging application, which shows the communication that goes on behind the scenes between the phone and the server. So why on earth would I make something like this when we already have access to free Wi-Fi and data connections all over the world? I come from a country where I get 2 gigabytes of data every month for $80, and the prices for internet are so expensive in this country that 750,000 people are still using dial-up internet connections in their home. I come from Canada. So the data prices are so expensive just when I'm at home in my own country. So whenever I'm traveling, I have to pay an arm and a leg just to be able to browse the internet. Like to be here right now, I'm paying $100 just to get access to 1 gigabyte of data. And this is kind of an issue for me because I really, really love to travel. And I spend a lot of time in places like Paris where the streets look like this. They're kind of all over the place. And I am extremely directionally impaired. So I get lost in New York City where the streets are in a grid and numbered. And I end up in these situations when I visit places like Paris where I'll walk an hour in one direction and I'll have to figure out how to take the subway to get back to where I was originally trying to go. So I could technically download an offline map and use that to figure out how to walk around. But when I want to take the subway, that's the kind of thing that requires up-to-date, real-time information, and you can't get that online. And so I decided to do something about this. And one of the first things that I noticed when I started trying to solve this problem is that my phone plan has unlimited SMS in most countries or very, very cheap messaging. So originally, a couple years ago when I started this, the big thing at the time was building chatbots, and a lot of companies started building these interfaces through like Facebook Messenger or whatever. So I decided that because I have unlimited SMS, I'll build a chatbot. And the way that it worked was I would be able to send a message like, how do I get from here to there? That message would be sent to my server. My server would have unlimited access to the internet, so it would use the Google Maps API to get those directions and text them back to me. So I could do this in France for about 15 cents, and I would get all the directions that I needed real time. And I use this a lot, and it had a lot of things like being able to store address books, so I could just say, how do I get home? You could say, I want to get there at 4 p.m. It would do that for you. But it was so useful that I kind of got addicted to having access to the internet. So I would want to look up a translation of a word, and I built an API integration for that. Or I'd want to look up the rating for a restaurant I was next to, and I built an API integration for that. And I started spending so much time building all these one-off integrations that I decided, this is kind of silly, I shouldn't be doing this. I should just build a browser instead. And that is what we're going to go over now. There are 2 parts to this project. So there's the Android app on one side and the Node.js server on the other. The app I built in Android because I figured this is something I'm going to use, so screw iPhones. I did it in Java and not Kotlin because I was completely new to building phone apps. I had never worked with the SMS API, and I figured there's a lot more on Stack Overflow about SMS with Java, so I'm going to go with that because of the community around it. The server I built in Node.js because I thought it would be really funny to put JavaScript on the server where it does not belong to create a browser without JavaScript where it's supposed to be. For the communication between these two parts, I used Twilio. So Twilio is a really great company that has a lot of different services all around communication and messaging. The part that I used here is something that lets me forward SMS to a server. So what I've done is I bought a number on Twilio, and every message that I send to that phone number will be sent as a post request with a bunch of information about the message to my server. To set up the limitations that I had to deal with for this project, so I want to transfer an entire web page over SMS to my phone, but SMS only allows for 160 characters at a time, which is about the size of a tweet. So it kind of is discouraging already to have to transfer a whole bunch of messages this way. And even more so, if you look at a page that's very simple like Google, all we think about when we look at this page is the input and the button and maybe the word Google. But when you actually look at the source of this page, this is 250,000 characters in HTML. So if we were to break this up into messages and send it over without doing anything to it, it would take 1,300 SMS to get there. And this would cost me $10 in Twilio fees alone, which is a lot more than I was willing to pay. But when we think about what that web page looks like and the functionality behind it, we really only think of it as being the form, the word, the input, the button, and it's very, very small and fits into a single SMS. And so when I was going about this, I decided that any web page I have, I'm going to want to make a programmatic way to get it down from this big bulky thing to a tiny thing that just represents the interactions that I want to have with it. So we're going to walk through the life cycle of requesting a website and then actually getting around to rendering it. Right off the bat, when we want to request a URL, we end up with a pretty big limitation. URLs, the spec says that a URL can be 2,000 characters in length, which could end up taking 13 whole SMS. So when we start off by requesting a URL, the first thing we're going to do is take it and chop off the HTTPS www, because it's assumed that every website has that anyway, so it's just going to take up space in the message. The browser that I built also isn't going to support any kind of tracking information or like fancy JavaScript stuff, so anything that falls after the real part of the URL is something we can just get rid of. So if we have a URL like this, we can just use the yellow part that's highlighted and send that over SMS. And to do that, Android has this very, very simple SMS Manager API, which is just lines 9 and 10 here. This took many hours of Stack Overflowing to figure out. It was very difficult, but really all you have to do is get permissions to send, receive, and read SMS, and then initialize the SMS Manager API, specify the phone number you want to send the message to, specify the body of the message, and then it sends it off for you and takes care of everything. So then this message is sent to the Twilio number that I own, and Twilio takes that and turns it into this very, very big JSON blob with a whole bunch of information. And I've highlighted the parts that are really important here. So at first we have the body, which is just the URL that we're requesting, the to number, which is the number that I have, and the from number, which is the number that we're going to want to send the data back to at the end. So this is sent to the server, which then has to do a lot of processing. So I spend a lot of time working on React components, which when you look at them on their own are very, very small, tiny things, and I kind of forget sometimes just how big our websites end up being. So I accidentally press view page source pretty often when I mean inspect element, and I see this wall of HTML that looks horrible and it's impossible to understand looking at it like this. And this is the HTML that the server has to deal with when it's trying to figure out how to send this over SMS. But there are a lot of things in this HTML that we know we can get rid of right off the bat. Like we aren't going to support JavaScript, so we can get rid of all of that code. We're not going to support CSS, so we can get rid of all style tags. We're not going to support things like images. So the first thing that happens to get that HTML is on the Node.js server, we're using Express to set up this web application. So we're going to start by grabbing that URL from the text message, prepending HTTPS, so it's a real URL, just getting the HTML for that page, and then loading it into a library called Cheerio. And Cheerio is like jQuery for the server. And all we're going to use that for is to get the body of that page so that we already have a much smaller subset of code to deal with. The next thing that we're going to do is use this library called Sanitize HTML. And this is a library that lets you determine what tags you want and what attributes on those tags you want. And then you pass it some HTML, and it will filter that down to just what you want it to be. So I figured that in this very simple browser, the only tags that I really care about other than text are anchor tags, input elements, and forms, because those are the things that let you access the rest of the internet and really interact with a text-based website. And then on those tags, the only attributes we really care about are things like the value, the type, the name. So anything that's class or data, like we can get rid of because we don't have CSS, so allowing class tags or class attributes would take up quite a bit of space that we don't really have the ability to use. The last part of Sanitize HTML here is this exclusive filter, and that's something that lets you set up a function of the tags and attributes. So for example, we want to hide all hidden inputs because we're not going to be able to see them, so it's kind of wasted space. And then also we want to get rid of privacy policies and terms and conditions because we're not going to click on them, so there's no point in setting them. At this point, we have a lot of text and a couple of different HTML tags here and there, and so we have to start compressing the English text. And the logical thing to do at this point is to run this through gzip and send that. But this is not a logical problem. So the first way that I decided to compress the text is by doing character replacements for really common words. So the word the and are extremely common in English, and there are a lot of letters in English that aren't used, like everything except for A and I. And so what I decided to do is replace these common words with the single letter variations. So the becomes T, and becomes ampersand, and like so on and so forth. And this is a really easy compression to decompress on the Android side because we know that if we see a single letter on its own that is not A or I, it's clearly supposed to be that other word. So we can do this for the 24 letters that don't mean anything, and then we can start doing the combinations of 2 letters that don't mean anything, and we can compress a lot of words in the end this way. To do that, all we have to do is set up this mapping of long word to short word, and then just go through that mapping and do a replace all. We don't care about the structure of the HTML at this point. It's probably going to be okay. If you're visiting a website like Wikipedia, there are probably a lot of really big words that don't need to be that big. So penitentiary is a 12-letter word that in most contexts is going to mean the same thing as jail, which is a 4-letter word. So we can use a thesaurus API to find these long words, find synonyms for them that are really short, and replace those. This is not a reversible compression. So on the Android side, you could take all the very short words and find the longest possible synonyms for them, but you're going to get some interesting results. The next way that we're going to start compressing things is by replacing links. So when I'm on my computer, I have the proper behavior of hovering over a link before I click it, seeing that it's a good, trustworthy link, and then clicking on it. When I'm on my phone, I just click on the link and I don't care where it goes. And I decided I should take advantage of that behavior. So what I do here is, let's say I have a link in the real HTML that goes to fellow.app. What I can do is replace that link with a 3-character long random string, send that over to the browser or to the app, and then when I click on the app, that that thing is sent back to the server, and then the server knows, oh, this isn't a real URL, I should figure out what it's supposed to be, and then get the HTML for that correct link. And this saves a lot of space on a lot of websites because websites are covered with links, and sometimes the words that are linked are really, really short, but the URLs tend to be extremely long. So this saves a lot of space. And the way that I do this is by using Redis, which is a in-memory key-value data store. So for every URL that's encountered in the HTML, it's passed to this URL shortener function, and it generates the random string, and then it sets the value in Redis as phone number underscore short URL, that's the key, and then the value is the real URL. And this, so setting it with the phone number first reduces the chances of there being collisions, but there still is the chance that you'll get the same URL stored under the same short link, but that's okay. It's all going to be our own URL, so it's not a big deal. Okay, so the last way of compressing the HTML is by using Greek characters. One of the great things about the SMS character set is that it allows for Greek characters, and most of the websites that I visit, at least, do not have Greek characters on them. And so I decided to take advantage of that. Now, because we have such a small subset of HTML tags and attributes, I figured there's this way of mapping all of these combinations to the different characters. So I've color-coded the original version and the shortened version here. So like the bracket input is that first one, type equals quotation mark is the second one, and it might look a bit odd that the words are combined with the different like equals and quotation marks, but we know that type is always going to be followed by an equals and then a quotation mark, and so we can do this because we have enough characters in the Greek letters to do this explicit mapping, and this shortens it quite a bit. One of the issues with SMS is that it does not have guaranteed delivery or a guarantee that it will arrive in the same order that it's sent. So we might end up with a situation where we have 6 messages sent, 2 of them never make it, and then the 4 that do arrive completely out of order. I decided to ignore the fact that some SMS might not make it. In order to recover from that kind of issue, it would require building out an entire networking system, and that was a bit above what I wanted to do with this, because if some of the messages don't arrive, you can just reload the page and it's not going to be a huge issue. But for the arriving out of order issue, that's quite a big thing with my phone. So what I've done here is if these 3 messages make up the entirety of the HTML to be sent out, we're going to prefix them with some metadata that specifies the number of messages that are in this page and then the index that they fall under. So we know after getting the first message, we have to wait for a total of 3, and then once the 3 arrive, we know what order to place them in so that we get actual valid HTML at the end. And to do this, Twilio has a great Node.js library, so all we have to do is say messages.create and then specify the body of the message, who the message is from, and then the number that it's going to, which is something that was sent in the post request earlier on. So now this is being sent back to the phone, and the way we receive it is through something on Android called a broadcast receiver. And a broadcast receiver is something that you can set up to listen out for different signals for events that happen within the phone. So here I have one set up to listen out for incoming SMS. And what this does is it just waits for all the SMS, not shown here, very condensed, but waits for all the SMS and then sends it off to an activity, which is Android's version of View. So once we have all the SMS and we've concatenated them together, we have to start by reversing the Greek letter conversions so that we have some real HTML to deal with. Reverse the shortened English words, so not the thesaurus way, just the single letter shortening. We're going to add some spaces between the closing and opening tags just to add a little bit of visual interest to the page because there's no CSS, there's nothing, so we got to make it a little bit more readable. And then we're going to load it in a web view. So if you've ever opened Slack and clicked on a link and it opens Chrome within Slack, they're using a web view component. So a web view is Chrome within an app, and you can either send it a URL to open, or amazingly, you can send it some HTML to open, which was the best discovery in the world because when I was building this, I thought for the longest time that I was going to have to build my own rendering engine. And I almost stopped. And this is what it looks like. So on the right side, we have the actual message that was sent to transfer all of google.ca, and on the left, we have the rendering in the app of that web page. So this this is pretty on point with what Google looked like 15 years ago. So it's not too bad. When I started this out, I set a goal of getting this web page down to 10 SMS, and I thought that would be a completely unattainable, amazing thing to do because it started off being 1,300, and I got it down to 3 SMS for this whole page. So, so once I did that, I was really interested because this project is named Dial-Up. I was curious to see how fast is this compared to actual dial-up. On my phone on a good day using a regular browser, it takes 2 seconds to load this page. On dial-up a couple years ago, it would have taken 45 seconds to a minute or so, and using this method over SMS, it takes 10 seconds, which when it's the only way you have of accessing the internet, that's not long at all. SMS is not secure at all. SMS has the capability of being intercepted, it's not encrypted, it's not secure, so this is not something that should be used for anything password related, anything credit card related, anything like that. So one of the things that I do is get rid of sign-in links, because if we're not going to click on them anyway, why use the space? But on the other hand, because this browser does not have any tracking or any cookies or anything like that, this is more secure than a lot of browsers. One of the ways that this project could have been quite a bit easier is using MMS instead of SMS. And so that only costs a fraction of a cent more, and it supports quite a bit more data. But just like gzip, that is just not a fun solution. So, there are a lot of things that could be done with this project. So we can do things like WebSockets, because phones and SMS are by nature bidirectional communication. So the server could just send a text message to the phone whenever there's a new notification. There's nothing fancy to be set up there. We could do things like AJAX. So if I visit Twitter a lot, I could store the HTML and the CSS required for that web page on my phone ahead of time, and then use these requests to only get the contents of tweets or the content that really changes. We could also add support for JavaScript. Or my favorite one is support for real dial-up. So through the Android API, you can also make voice calls. And I thought it'd be really cool if, instead of doing SMS, if it did real dial-up, where you initiate a phone call, the server and phone go back and forth for a couple seconds, and then all the data for a website is transferred that way. Because it would probably only take a couple seconds and might end up being cheaper and more reliable than SMS. So that would just be super cool, going backwards. So I did not know about travel SIM cards when I started this project. I found out about these a few months ago. If you don't know, you can get a travel SIM card for about $20 or $30, and it gives you access to about 20 gigabytes of data in whatever country you're traveling to. In comparison, I pay $80 for 2 gigs, so this is a great solution, and this is what I do now. If you want to get in touch with me or check out more about the project, here's my website and Twitter. Thank you very much.